Our next session, featuring David Fauth, is just about to start. If you have questions during the presentation, please submit them via the Questions tab. We'll do a brief Q&A at the end of the session. So without further ado, here's Lance Walter, CMO of Neo4j, who will introduce our next session.
All right, well, we've got a session from our own Dave Fauth, who is a senior field engineer here at Neo4j. He's been with the company for a little over 6 years. And what Dave does is work with customers to really understand some of their data challenges and show them how they can deliver data breakthroughs with Neo4j. Dave has a lot of experience in systems engineering, architecture, and integration, and he's worked at organizations including McDonnell Bradley and IntelliWare Systems. Dave has a Bachelor of Science degree in Marine Engineering and Marine Transportation from the U.S. Merchant Marine Academy and a Master's in Information Systems from George Mason University. Dave's here to talk about integrating streaming data with graphs, so let's dive into it. Welcome, Dave.
Thank you, Lance. I'm happy to be here to present this topic to our Connections audience. Thank you for joining today, wherever you are. My name is David Fauth. I'm a field engineer at Neo4j. And today I will be talking about the Neo4j Kafka connector best practices and ways to ensure success. So just like a peanut butter cup where chocolate and peanut butter go well together, Neo4j and Kafka also go well together. Kafka is a great tool that we see often in the field for bringing data, especially streaming data, from various different systems into Neo4j, and it really supports some great use cases around fraud detection, network event detection, basically anywhere that you want to stream data into Neo4j and do that easily and simply. And it's also a technology where we can also take change data capture from Neo4j and write that data back out into Kafka and allow other systems to consume that data. So to make sure that you're successful with Neo4j and Kafka, we want to provide some best practices for leveraging Neo4j and Kafka. So today we'll give an overview of Kafka. We'll talk about Neo4j streams or the Kafka Connect Sync, or two ways of getting data from Kafka into Neo4j. We'll talk about a few keys to success, some things to be aware of and some things to just work on, know about. And then we'll do a short demonstration where we publish some data to Kafka and allow Neo4j to read off of a topic and write that data into Neo4j. All right, we'll talk a little bit about Kafka. So I'm not a Kafka expert, but I wanted to at least lay the groundwork of what Kafka is so we understand why it's important and how it can be used. So it's a distributed streaming platform. It publishes and subscribes to streams of records, similar to a message queue or an enterprise messaging system. It can store those messages in a fault-tolerant way and process streams of data as they occur. So we have producers that write data to these brokers. We have consumers that read data from brokers, and they write these to a topic. And we can have multiple topics within Kafka, usually around a specific type of data or piece of data. We can have 0, 1, multiple number of topics or that consumers can read from. So a topic can have 0 consumers, 1 consumers, and number of consumers about that. We write the data into those topics, and then those topics are split into partitions. So the producers can stream a set of data to those topics, and then the consumers will subscribe, listen, pick up the data off of those topics, and then hand that data off. And in our case, we'll hand that data off to Neo4j. Kafka provides a connector API, so it allows us to build these reusable connectors that connect the topics to the applications. And that's what we'll talk about with our Neo4j pieces of software. So our first component that we have to connect Kafka and Neo4j is Neo4j Streams. This is a plugin that Neo4j provides. It allows you to consume messages from a topic and write that to the graph using Cypher. It can be configured on a per topic basis and on a per database basis. So when we configure this in Neo4j, we tell it how to connect to Kafka. We tell it which topic we want to listen on. We give it the cipher that we want to use to transform the message into Neo4j. And then we can also tell it which database to write that data to. It also allows us to produce messages from the graph. So if you have a change data capture requirement where you want to track changes in the Neo4j graph, write those out to Kafka to be published on a downstream system or some other application, we can support that as well. There are a couple caveats around this that you need to be aware of. Since the configuration and the information is stored in our neo4j.com file, any changes to that requires a restart inside of Neo4j. It's just something to be aware of. If you change the plugin, if we release a new version of the plugin, you will have to download that, install that on Neo4j, restart that server, do a rolling restart across your cluster. And then it's on your shoulders. You're required to make sure that your Neo4j configuration settings are consistent across all of the servers in your cluster. It's a great piece of software, really easy to use, very powerful, but again, just be aware of those 3 caveats. The second option that we have is a Kafka Connect Sync. This is really the easiest way to deploy a connector to get Neo4j or to get data into Neo4j. It's got some great flexibility on what data you can pull from Kafka and what goes into Neo4j without touching the database. Since it's outside of Neo4j, you don't have to take into consideration impact on the CPU or impact on the memory. You just deploy it writes data into Neo4j. It's much easier for pros to manage. You'll benefit from the Confluent ecosystem, all the things that wrap around that. And just by restarting the worker, you can restart your sync job. So it eliminates that need to stop Neo4j and restart Neo4j. The one downside for this is you cannot do any transaction event handlers outside of the Neo4j database. So you will not be able to use this for your change data capture requirements. So let's transition now to some areas of focus on our best practices or keys to success. Our first key to success is around ETL, extract, transformation, and loading. So this is really, I would say, the most important thing to consider. It's really going to impact your performance and your success with the tool. It's just one thing that we really need to be aware of. One thing to realize is that Kafka data is not in native graph format. It's usually in JSON format or Avro format. It's just a stream of data that we want to extract that data, and we're going to have to transform it into a shape for the graph, and we'll have to load it into the graph. So this is a common use case for Kafka, the streaming ETL piece, but we want to make it simpler. We want to be smart about how we do that, how we extract this data, and how we write it into Neo4j. So what does that mean, the relevant data? We really only want to write out to this topic the data that we need for the nodes, properties about the nodes, and the data that we need to connect nodes together to form the relationships, and the properties that we want to add onto those relationships. So we want to simplify this ETL, and there's different things that you need to think about and be aware of. So we want you to understand nodes versus relationships and understand a little bit about what happens inside of Neo4j. When we write a relationship, we lock both ends of that relationship. We lock the from node and we lock the to node. So as we're writing, we want to make sure that when we pull off the topic, that we can write those relationships efficiently and effectively. So that means we may not be able to parallelize that streaming process because we may end up with several errors or several locking situations, and we don't get the performance that we expect. If we're just writing nodes, we can parallelize that process. We can write different types of nodes. We can leverage multiple topics from Kafka, multiple consumers to pull off of those topics, and write nodes in parallel. There was a recent talk on the Nodes 2020 conference about a strategy for parallelizing relationship loading. I highly recommend that you go look for that. I believe it was from Deloitte. So it's a great topic, a great talk about a strategy for parallelizing relationship loads. Another strategy is use Kafka. Don't use Neo4j for everything. Neo4j isn't the best, the most optimal for that transformation piece. So Kafka has KSQL. It has other ways of doing that data extraction transformation before it gets to Neo4j. So when we write it onto the topic, we can pull off the data. We can easily load it. We can create the simple nodes, the properties, without doing a lot of if case statements that slow down the data loading. Which really ties into our next comment about don't do complex ETL in Cypher. It really gets really complicated to have a 30, 40, 50 line Cypher statement inside of your neo4j.conf that you're trying to figure out. It's much easier to do that in Kafka, to stream that, to simplify it, maybe use different topics. But again, try not to push complex ETL into your Cypher code. It will slow it down. It will just be harder to maintain and harder to understand. Keep it simple, obviously kind of redundant to what we've talked about so far, but keep everything simple. Again, we don't want to make Neo4j a complex transformation tool. And our final point on this slide is to keep the topics consistent. So again, if you may have to mix nodes and relationships into a topic, but if you have a topic for people and a topic for emails and a topic for addresses, try and keep the people data in the people topic, the address data in the address data, and the email data in the email topic. So for high throughputs, we do have a link for more details on this at the bottom of the page, but we can use multiple Kafka topics. So if we understand our node relationship locking issue inside of Neo4j, we can use multiple Kafka topics. And we can build a data pipeline that pulls data from those topics. So we could pull all of our nodes in parallel, do a high throughput, writes to that, pause, and then pull data from our relationships, single thread that because we don't want to run into some locking issues, and complete that. So there are different strategies that we can do just to leverage these multiple Kafka topics and run things in parallel. We'll want to use some stream transformers and KSQL techniques, again, to craft the messages. So keep them simple. Don't overload that topic with extraneous data, extra properties that never make it into the database. So again, keep it simple, keep the messages clean, keep them simple. And then finally, let's experiment with some settings to get optimal performance. There are different settings within Neo4j. There's different settings within Kafka on the batch size, on the amount of data that you pull, the number of bytes, the retries. So you'll want to experiment with those settings with your data, with your hardware to get the optimal performance. Another key to success is proper configurations. So we don't simply roll Neo4j out or Kafka out into production without understanding configurations, without tuning those configurations for our optimal performance. So on the Neo4j configuration side, and this applies to both the Kafka Connect Sync and the Streams plugin, is we want to understand page cache and heap. So on our page cache, this is where we load the database into memory, where we map the Neo4j data files and our native indexes into memory. So we want to ensure that our server has as much memory for the page cache as we have for the database and the indexes. Ideally, we load that into memory. So if our database and indexes are 100 gigabytes, we want to have a page cache of at least 120 gigabytes to allow for growth. So ensure that your hardware is sufficient and your page cache is set correctly. And for our heap, generally we start with 12 to 20 gigabytes of memory. Our heap is where we're going to use that for our transactions, for writing into the database, for any of the data manipulation, if we're changing it to integers, to floats, any of that data manipulation within the Cypher will take care and be handled in the heap. So we want to ensure that we have sufficient heap to avoid any long garbage collection pauses. We can configure the batch size. So I believe by default it's 10,000 records, but you can configure the batch size. Maybe you want to update that to 10,000 or 20,000 records, or maybe you need to throttle it back to 5,000. It's something that you want to experiment with and find out what the sweet spot is. You can set the batch timeout, how long the batch will run. On the Kafka Connect sync, you can set it for parallel true. You don't have that option in the Streams plugin, but the parallel allows you to run those parallel processes. So again, if you're writing a lot of nodes out of your Kafka topics, you could set parallel true and get greater throughput. Query logging. So you want to ensure that you turn off the Neo4j query logging in production. Otherwise, you're basically creating a lot of data, a lot of log files that Neo4j has to manage. You're basically duplicating the queries at least twice. So again, you can be smart about that. Configure query logging to just monitor long running queries. And then on the Streams plugin, really just understanding the number of records per batch. That's what we want to keep track of. How many records do we want to batch up per transaction within Neo4j? Again, on the Kafka configuration, there's a couple things that we want to keep track of and be successful with. These are important, but they're really not the exhaustive list. So acknowledgements, the axe is really there to determine how many of the brokers receive the record before we consider it committed. So again, you can do it for one, where it makes sure that it gets at least one in-sync replica available. That's a good setting for latency. If you want to make sure that all of your Kafka cluster members have the record, you can set it to all. It'll be good for durability. It's tied to the number of in-sync replicas. You can set it to 0 and it will just write. You get really good throughput, but there's no guarantee on the durability. So it's kind of that trade-off on how fast do I want to write data versus how comfortable I am and how much guarantee that I want that my data is being committed. On the consumer, we use the Kafka enable auto commit true. So that's just a setting that we use. That's our default setting. So our min.insync replica setting is a configuration on the broker that denotes the minimum number of in-sync replicas for that. So if our acknowledgements is at least 1, we'll want to set the min.insync.replicas to at least 1. Again, it depends on how comfortable you are with latency versus durability. Neo4j defaults to use a Kafka setting of kafka.enable.autocommit true. This provides no guarantee, meaning that each message could be processed multiple times. So we default to true. You just need to handle that in your cipher statement. So in my case, we'll use merge, understand how to do that so we don't duplicate data or overwrite data. And then we have a new setting. This will be coming out in, I think, a new release or the next release about async commits versus sync commits. We can tweak this to get much better throughput. But again, you have to understand the trade-offs. So commit sync is a synchronous commit and will block until either the commit succeeds or an unrecoverable error is encountered. So that's going to block. It's going to be a little bit slower. Commit async is an asynchronous call. It does not block and does not provide an internal retry mechanism. So if you want the data consistency, you want to do the sync commit because it will make sure that the commit is successful. Again, if you want low latency and there's no guarantee, you don't need a guarantee of data being ordered, you can use it commit async setting. Okay, so we're getting towards the end of our keys to success. So the last key to success that we have is error handling. And we know that at some point I'll get an error, you'll get an error, we'll all get an error. So what do we do when we get an error? So there are a couple of potential issues that we see with errors. The message could not be processed for some reason. Someone puts a different schema into your topic that you weren't expecting. So a couple different errors. We just need to know how to handle those errors so you're successful. So in the Neo4j configuration, we have 3 options. So the first one would be, I want to fail fast and stop. So I'll set this setting in my Neo4j conf that says errors.tolerance equals none. Another option I might have is I want to log the errors and continue. So I will set the errors.tolerance equal all, enable the logging, and include the messages. And then the third option would be to write out to a dead letter queue so we can take a look at these topics or the messages later and see what happens. So we'll set up the errors.log enable true. We'll include the messages to true. And we have an option to set the dead letter queue topic .name to be a topic name. So this is a topic that you've created in your Kafka server. If there's an error, Neo4j will write those messages out to that dead letter queue. So 3 options for you. There is no cure-all solution for this. Just make sure that you handle the exceptions. Figure out your plan for handling them, enable that plan, and continue going forward. So let's summarize what we've talked about so far on the Kafka and Neo4j piece. Just our things to do for keys to success. Simplify our ETL. Again, I can't emphasize that enough that Neo4j is not a transformation and loading tool. We're a graph database. We're excellent at being a native graph database. So help us out by simplifying your data, simplifying the data that goes into the topic. Do those crazy transformations and data manipulations with the Kafka tools, with a KSQL, with other ways before you write the data onto that topic. Understand Neo4j operations. So if you're new to Neo4j, please ask questions. There's a great community that will help you, whether it's on our public Slack channel or community page, or reach out to your pre-sales engineers, your post-sales engineers, your customer success team. Understand the impacts of how we handle memory, how the database works, the importance of indexes, locking, nodes versus relationships. So you want to be smart. We want to help you be smart. We want to help you be successful. We want you to understand Kafka. So there's a lot to learn there. I'm still learning as I go along. Talk to your Confluent people if you have a contact there. Have them help you configure properly. Understand how you can set up topics, the best practices for partitioning, your latency versus durability. So again, understand Kafka, be smart about it, be smart about your configuration. Our fourth key there is to configure Kafka and Neo4j properly. So there's different settings around memory usage, around durability, acknowledgements, how long to keep data inside of Kafka, when to roll that data off. So there's a lot of things there to think about and to configure. There's several guides out on the Confluent side, as well as other internet blogs and posts about configuration. So be smart, do your research, configure it properly. And then just follow the best practices, basically the 4 things that we've laid out here. There's some other really good Neo4j best practices, but again, if you're new to Neo4j or new to Kafka, please reach out. It's definitely a new technology. Be smart about it. Don't be afraid to ask for help. So in summary, if you're unsure that you can do all of these things, you may want to consider using a cloud service. So there's Confluent Cloud that will manage your Kafka, just take that load off of your plate. You can just write data to it, read data from it. And if you don't want to manage Neo4j or manage the Neo4j cluster and all the DevOps piece around it, we do have Neo4j Aura, or cloud-based database as a service. And we'll handle all the backups, the updates, the upgrades, allowing you to focus on your business. We can work those 2 together. We can read Confluent to Aura, Aura to Confluent. Great partnership. So if that's something that you are interested in, you can always reach out to the Neo4j sales team, and we'd be glad to talk to you about that. So we've talked about a lot of best practices. We've talked about that it can be done. So I'm going to just show you a quick demonstration using the Neo4j Streams Kafka plugin. We'll look at the configuration. We'll write some data out to Kafka, and then we'll have Neo4j pick it up. So I'm going to transition now to our demonstration. And then once the demonstration is over, we'll come back. We'll have some time for questions and answers. So right now I'm in the Neo4j browser, and I'm just going to go ahead and delete my few nodes that are in here and just reload the browser. So we have no data in our default database for Neo4j. So we'll just show you the configuration. So for the Neo4j configuration, we have some connections. So we're going to connect out to our Kafka server on port 2181 for Zookeeper. We'll bootstrap to our Kafka server on port 9092. You can have, if you have a cluster of Kafka servers, you can have all of those server addresses listed there, so we can try multiple of those. Our offset will be earliest, so we'll go back to the earliest messages, reprocess those. We've added a group ID here for Neo4j. If you have multiple different Kafka consumers running, you want to assign those a different group ID. Our acknowledgements are all, retries are 2, and we'll do some defaults here for batch size, buffer memory, and polling. Here's where our sync, here's my error handling thing. So we have a dead letter Q topic name. So I call it connections underscore Neo4j underscore DLQ. Probably not a good practice because you're not really supposed to have underscores in your topic name. We'll add a context header prefix here, allow headers. We'll tolerate all errors. We're going to enable logging of errors, include the messages, and we've enabled the sync. So when we start up. And then here's our cipher that's going to take the message off the topic, transform it, and load it into Neo4j. And this does a basic unwind, so we'll unwind a batch of messages and run this cipher query. So we have our streams.sync.topic.cipher, and here's our topic name, connections email. Inside of our topic, the message is going to have a from ID. It's going to have a person name. It'll have a to ID, and it will have an email address. So we're going to merge this person ID. We'll merge an email ID. So we'll create a person node with an ID property and a name property. We'll merge the email, give it an email address ID property. When we create it, assign it an email address. And then we'll create the relationship. This merge P has email E. So we'll jump out to my server that I have running. So if I run Kafka cat, I can see some sample messages here. So in this one, I have a label that's person to email, just some extra data. Our from ID is 93, our to ID is 93. Here's our person name, Tiffany Diaz, email address, Jonathan, and a phone number property. So I wrote a little Python application here. So Python application just basically create some random data. It's going to create some random sequential IDs, a random person name, a random email, random phone number. So we'll send 500 items onto the producer. We'll just Kafka cat. With Kafka cat, we see we have up to 499 Jennifer King. So let's go back to Neo4j. We'll just reload him. And you can see right now that we have our person nodes, our email nodes, and we've created the relationship has email. So let's just see. We'll find from ID 499. So just to find Jennifer King. And there's a node that we created that we pulled from the Kafka topic, brought into Neo4j. We can click on that. Here's a has email relationship written out to Natalie. Very easy, very quick to load that data, easy to configure. It's really a lot easier than writing some complex load CSV statement. You can do a lot more with this Streams plugin and with the whole Neo4j Kafka configuration. So I know that was a pretty simple demonstration. Again, if you have multiple topics, we would create multiple Cypher statements to read from the topics. We can do a little bit more complicated Cypher, but again, our goal is to keep that simple, keep that topic data simple, and enable us to pull that data off of the topic and load it into Neo4j quickly and easily. So with that, I think we'll be ready to do some Q&A. So I'm just going to leave this up here, and I think we'll take some questions from the audience. So thank you again for your time. Thanks for being a part of the Connections event, and let's see what questions we have.
Great. Thank you so much, David. Such useful information. Very valuable. Thank you so much.
You are welcome. Thanks for the opportunity to present this.
Oh, absolutely. And we do have some questions that have come in while you were presenting. So I want to get to those and also remind the audience that if they want to submit questions, they can do so by typing them into their questions tab. And if we don't get to all of them, someone from Neo4j will reach out, or they can send an email to webinar@neo4j.com and we'll get them pointed in the right direction. But like I said, we do have a few that have come in, so let's get started with those. So one of the questions asks, does the Neo4j Streams connector support SSL between Neo4j and the Kafka server?
Yeah, so the question is around security. So let me just bring up, let me find our documentation. So we try and do a great job on our documentation. So you can always go to neo4j.com/lab/Kafka. And we have this section on configuring with Kafka over SSL. So we can authenticate with SASL. We can do some encryption on authentication with SSL. So there are some examples here, just really on how you would connect to it. It does take a little bit of work on your Kafka server to configure it properly, but hopefully these examples will get you pointed in the right direction.
Oh, perfect. Thank you. Thank you for showing us where they can find that on the website. Another question asks if you can talk a little bit more about the CDC capabilities with the connector.
Yeah, that's another great place to talk about. So let me see if I can find that on our website here. So we'll come back to that question. Let me just find the right page and let's ask that question again.
Okay, so here's one in the meantime. How could you stream query results from Neo4j to a Kafka topic?
Yeah, that's a great question here. So let me just pull up my other example. So Neo4j has a procedure. So we have a procedure called streams.publish. So this is an example of running a graph data science algorithm. So the GDS.PageRank. So we'll stream out results. We can create a little map here as a result set. And then we can call this streams.publish, which we will talk to a topic that we have identified in our neo4j.conf. In this case, it's NeoRR. And then we'll write that information back out to that Kafka topic. So we can pick it up with another Neo4j database or another downstream server.
Great, thank you. And we are running a bit tight on time. I don't know if we want to go back to that question. The one about the CDC capability?
Yeah, let me just See if I can find that really quick. I know it's talked about here. So it's a configuration that we set up inside of the neo4j.conf file. And basically, we identify which nodes and which properties by label that we want to publish out. We also can identify which relationships. So as changes occur, we can write those out to a Neo4j topic. So it is documented. I just don't have it at my fingertips right now. It is a predefined format, so it's something you want to be aware of. So we do write a little bit more of a more detailed format to that CDC topic. So it's something to take a look at and be aware of. So I know we like to say we want tight ETL, but the CDC from Neo4j is a little bit more detailed JSON format.
Okay, great. And then we can also follow up with that person directly. So no worries. But we are about out of time for this session. I want to thank you again, David, for sharing this with us. It's so much useful information. And I want to thank the audience for being with us, and stay tuned. The next session will be starting shortly. Thanks so much.
Thank you.